All right, 2.6, the last thing we need to cover is step functions, okay? And step functions are another special type of function that we work with, absolute value, piecewise, and step functions honestly are a type of function that's going to look like stair steps. That's why they're called step functions. And they are all a type of piecewise function. They come in pieces. Each stair step it's sort of like just the place you put your foot. They're not going to be connected. They're going to be separate steps. Sort of like a floating staircase, if you guys have ever seen something like that. I guess since you live in Florida, you probably haven't seen something like that. Now, the step function that we're going to focus the most on in this section is called the greatest integer function. And so, if you notice here, it's got a double bar to it. So it's like a bracket with a double bar. And if you want to draw it, I actually draw a bracket and then I put a bar inside of it like that. Okay? That's what a step function, that's what that means. That's the greatest integer function. And I got to teach you what the greatest integer function is. All right. So it means that the greatest integer less than or equal to x. This is really important. There's a value on the inside of those brackets, that greatest integer function bracket. That number will either be equal to that integer or goes down to the next smallest integer if it's a decimal or a fraction. And we're going to go through some examples of that, just so you can get an idea how this thing actually works. The greatest integer less than or equal the value of x. Here's some examples. Bless you. If I had 3.2, okay, the output value of the greatest integer function is always an integer. It can be equal to the next lowest integer if it isn't already an integer. So the output value for this is going to be 3 because it's the next smallest integer. At the same time, if I took the greatest integer function of 3, it can be less than or equal to x. So in this case, since it has to be an integer, it's less than x. In this case, since it's equal to an integer, it is also 3. Because it goes down to the next lowest integer if it's not an integer. If it's already an integer, it stays that number. Okay? The greatest integer function, and this is where it gets kind of tricky in your mind because of the word greatest. It never goes higher. The greatest integer function output will either be equal to or smaller than the number that you have. Okay? And there's obviously over here lots of different numbers that I can put in here that will give me an output of 3. Any 3 point whatever, 3 and a fraction, all the way up to 3.99999, that drops back down to 3. Okay? That's what the greatest integer function does. It makes it equal to or less than the value that you have, so long as the output value is an integer. Okay? That's what this function is going to do. Now, let's look at an example of a function and what it looks like and how we graph it and how we identify the domain and range. Now, the way that we're going to do this is with a table of values. And I'm going to start with this and then I'm going to talk about how this works. Because there's a number of values for x that when you put into the function will generate the same value because the greatest integer function always kicks out an integer that is equal to or less than the value. All right? Now, the best place to start of course, is with what value for x? 0. Let's throw 0 in there. Okay. And so here's kind of where I'm at. I've got the greatest integer function. Y is greatest integer function is 0 minus 5. Right? Well, what is 0 minus 5? Negative 5. And then, so what is the value of the greatest integer function, negative 5? It can be less than that or equal to it when it's an integer. So since it's already an integer, it just stays an integer. So I have a point, 0, negative 5. Now, what we're going to find out is that there's a lot of different values that you can put in for x that will still give me a final output of negative 5. Okay? And what we need to figure out is when will it become negative 4? Right? So, that's what I'm searching for. What are all the values for x that will still generate an output of negative 5? And what I'm going to show you is kind of how to think, but you don't necessarily need to write this down in your homework. I want you to write it down now, and I want to show you this just to kind of prove a point. Okay? For example, if I use 0.5 and I plug that in, okay? This is just to show you how the greatest integer function works. 0.5 minus 5 is negative 4.5, okay? Since it's negative 4.5 and I have a decimal, it has to go back down to the next lowest integer. What is the next lowest integer from negative 4.5? Negative 5. Negative 4 is bigger. Negative 5 is the next lowest integer. So this also gives me an output value of negative 5. And if I plugged 0.2 in, and 0.1 in, and 0.6 in, and 0.7 in, if I plugged all those values in, it would still give me a negative 4 point something. And so the next lowest integer is going to be negative 5. Okay? At what value will I finally be able to make a jump to negative 4? For x. What x value will I plug in to make it jump to negative 4? 1. Okay? When I get to 1, that's the place where it finally jumps to negative 4. Everything in between 0 and 1 will default and fall back to negative 5. Except for once I get to 1. Okay? So, when you're doing your homework and you're making your table of values, again, I don't necessarily need you to plug the values in that are decimals. What I want you to figure out when you look at your function is, when will it make the jump to the next integer? Because that's when the step will change. Because from all the values from 0 to 1, I'm going to get an output value of negative 5. Until it equals 1. And when it equals 1, it jumps to negative 4. So what you're going to see here, I'm going to write on the side, I have an interval. Okay? From 0 equal to 0, that's why it's less than or equal to, until I get to 1, where it's almost equal to 1, all the output values between 0, including 0, and almost to 1 are going to give me an output value of negative 5. So this interval is the length of the step. The step goes from 0 to 1, and then when it equals 1, it changes, and it increases. The value of y goes up to negative 4. So how long will the step for negative 4 be? So it's going to start at 1 until it gets to what? Until it gets to 2. So again, I come up with the length of that step. And the functions, I will tell you that the length of the step, in this case 0 to 1, 1 to 2, it's 1 wide, is not always going to be 1. Depending on what the equation looks like up here, the length of the step can vary. Now here's the thing that's nice, and this is why I just wrote and so on, because we don't need all of the steps. Once you come up with a couple of the steps and you figure out the pattern, that pattern will just repeat. So when it comes to graphing, you just have to follow the pattern. Okay? Now, let's get to the graph. Are we good? Everybody got this down? So I can move on to the graph. Okay? So here's the graph. All right. Now, I wrote those things down again. All right. The value for y is -5 when x is equal to 0 and almost all the way through equal to 1. Yeah, take a picture of this page and then we'll graph it all together. Let's talk about the first step, the red step, so to speak, right? This means the y value is -5. So I go down to where y is -5.
Right there.
Okay, correct. At 0, it equals -5. So what I'm going to do is I'm going to put a point at 0, -5. Okay, because it equals it. And all the values over to 1 are also equal to 5, and then at 1, it's an open circle. Because when x equals 1, what's the y value?
-4.
-4, so it jumps. So all the values from 0 to 1 give me an output value of -5. As soon as x equals 1, the output value becomes -4. All right, so let me show you. So I have another step, one above, because from 1 to almost 2, the value equals -4. And once I have 2 steps, we can just follow the pattern. Because the stair steps don't zigzag or anything like that. They stay going that way. So if you, at this point, if you're a Notability, circle, copy, paste, and you can just paste a bunch of steps. Because, and now how many steps you decide to draw is up to you. Right? I would do a handful. That's what I'm going to tell you. Okay? Do a handful going this way. Do a handful going this way. Because that's where my stair steps are going to come in. All right? So here's an example. And I just continue the pattern. So the red and blue I graphed from the work that I did on my table. And the black one are just repeating the pattern. I didn't do any work for them other than recognizing the pattern and copy and pasting. Notice again that each step starts with a filled in point and ends with an open circle. Because if you look at this interval up here, I've got closed, open. And once you establish the pattern, it will just continue. Now again, the length of my step is 1 because that's what we figured out from our table. Sometimes the length can be bigger than 1. Sometimes the length can be smaller than 1. That depends on the equation that you're given. So let me reiterate this because I've been watching you guys on your homework doing this. The values that you happen to choose for x are not the domain. Because I could just easily, or your friend could just as easily pick different values for x, and they would all be totally fine. So the way you have to interpret domain and range is you have to look at the graph and go, all right, first of all, we know that these steps go on forever and ever in both directions. Okay, they keep going. Is there ever, as you move from the left to the right, is there ever a gap in the x?
No.
Okay, because as soon as, for example, if I'm moving left on this or right on this step, it jumps to the next step and it's still covered by that closed point. And I keep moving right, jump to the next step, covered. There is no gap there. Okay, as I move left and right. So for my domain, it's going to be all real numbers. Now for my range, we look at the up and down movement and look for gaps. Okay? So if I start at this top step, is there a gap between this step and this step?
Yeah.
You bet. There's a huge gap right in here. Is there a gap between this step and this step?
Yeah.
Sure. There's gaps all the way down. All right? What are my output values? What are my y values for every step? What type of number is it? It is an integer. No fractions, no decimals. And that's the nice thing about the greatest integer function. Your output value will be an integer. Now, keep this in mind. It is possible that you could have the greatest integer function plus a fraction on the outside. So it might change it. But in this case, my range is just all integers. And there's my funky z, if you remember when we went over groups of numbers. The capital Z stood for integers.
Can we also just write
You could write the word integers, sure. Okay? Step functions are pretty much going to work like this. Again, the goal when you're creating your table is what x value will make the y jump to the next integer. And that's what drives what you do.